Alright, I just wanted to make this quick video to show you guys how to balance equations, or at least how I balance equations. You can always look up plenty of videos on YouTube that shows you how to balance chemical equations. There are many ways to do it, but this is the way I like to do it. First off, I start looking at elements that are not hydrogen and oxygen. So I just start over here, where the iron is. And I notice that on the right side, I eventually end up with 3 irons. So that's going to be the first thing I look at. So if I have 3 irons on this side, I'm going to go ahead and start balancing it over on the left side. So if I have 3 iron on the right, I need to have 3 irons on the left. So let's go ahead and put in 3. So now does this make sense? I have 3 here and 3 here. That looks good. Alright, well, since I have 3 on this side and I already have 3 on this side, that means this number here can't be anything other than 1. So I'm going to put the number 1 there. So now this reads, I have one group of Fe3O4, which means I have 3 iron, 3 iron. So that checks out. But since I put this 1 here, that means that I can't have any more oxygens than 4 on either side. So I have 4 oxygens on this side. So if I look over here, I see I only have 1 oxygen. So in order to get this oxygen to 4, I need to make this coefficient 4. So now I have 4 oxygens and 4 oxygens. So that balances out. Now, since I've put a 4 here, that means I have to apply this 4 to the hydrogens. Well, I already have 2 hydrogens here. So if I have 4 groups of 2 hydrogens, that means I have 8 hydrogens in total. So, to make sure that I have 8 hydrogens on this side, I need to add a 4 here, because 4 times 2 is 8. 4 times 2 is 8. 4 times 1 oxygen is 4 oxygens. 4 oxygens. 3 times 1 iron means I have 3 irons. And I have 3 irons here. 3 times 1. You see that? So now I look through this, and it's balanced. Let's go ahead and look at another example. The next one is sodium, Na, plus H2O. And that gives us sorry for the jump cut there. I had to restart the video. But let's take a look at our new equation here. Now normally I would say start with stuff other than H's and O's, but I think in this case it's a good idea to look at the hydrogens and oxygens because we have an interesting situation over here. On this side I have 2 hydrogens. On this side I have 2 hydrogens alone, but then I have a hydrogen hiding in this NaOH compound. So that actually gives me a total of 3 hydrogens. Now, I only have 2 on this side, and unfortunately there's not a whole coefficient I can add over to the beginning of here that will give me 3. Because if I put a 1, that would mean I only have 2 hydrogens that go over, and that doesn't work because I have an extra 1 here. But if I put a 2, that means I'm sending 4 hydrogens over, but I have 3. So we're going to need to choose a number that I can get to on both sides. Now, putting a 2 here would give me 4 hydrogens, which is cool because if I transfer over here, 2 of my hydrogens are being used up here, which means I have 2 more hydrogens to distribute. Well, there's 1 here, and it's connected to the O and the sodium. So, can I put a coefficient here that will give me 2 hydrogens plus 2 hydrogens to equal the 4 hydrogens over here? Of course. If I put a 2 right there, that means I have 2 sodiums, 2 oxygens, and 2 hydrogens. And I have 2 hydrogens over here. That gives me a total of 4 hydrogens, which is what I'm looking for over here if I put 2 there. So let's take a look at this. 2 groups of H2, which is 4 hydrogens, 2 hydrogens, 2. If I put a 1 here, that gives me 2 hydrogens. So 4, 2, 4 hydrogens, 2, 4 hydrogens. Okay, so far so good, seems to work. Let's check the other elements. Let's see. This is saying I also have 2 oxygens. If I come over to the other side, this 2 matches up with that O and gives me 2 oxygens. I don't have any other oxygens, so it looks like that balances out. 2 oxygens, 2 oxygens. This 2 is also telling me now that I have 2 sodiums. Well, I have 2 sodiums on this side, but I only currently have 1 sodium. So if I put a coefficient of 2 right there, that gives me my 2 sodiums to match the 2 sodiums over here. So let's check to make sure our equation is balanced. 2 sodiums, 2 hydrogen 2s, so 4 hydrogens, 2 hydrogens, 2 hydrogens, which is 4, 2 oxygens, 2 oxygens. Looks like that checks out. Let's look at another one. The next one we're going to look at is going to be KNO3 breaking down into KNO2 and then some extra oxygen, O2. Alright, let's go ahead and take a look. So this one looks pretty straightforward. This is all the elements that we need to convert over to this side. But you notice, sure, 1K, 1K, 1N, 1N. 3 O's, 4 O's. So we need to find a way that we can increase how many molecules we have of KNO3 so that we have enough over on this side. Alright, so let's take a look. What I'm going to worry about is I'm going to sort of worry about these KNOs first. So I know that I have 3 oxygen on one side and 2 oxygen on the other side, plus this other 2 oxygen. So I know I need at least 4 oxygen coming from over here. Well, once again, there's not a coefficient I can put over here to turn this into 4. If I put 1, that gives me 3. If I put 2, that gives me 6. But is there a way to turn these into 6 oxygen? Well, I have 4, and this one's sort of by itself. So if this one is by itself and it's worth 2, if I take 2 away from 6, which is what I need from over here, that gives me 4. Well, I think I can turn this into a 4 by adding a 2. So let's go ahead and try. I'm going to put 2 here. So 2 gives me 2 and 3, 6 oxygen total. Well, let's see if I can get the 6 oxygen over here. Well, this is 2 oxygen, so if I take 2 oxygen away from the 6, like that's by itself, I'm left with 4. What can I do to turn this into 4? Well, I can multiply this all by 2, right? So 2, 4 oxygen plus the 2 oxygen from here. So if I give this a 1 coefficient, let's see how that stacks up. 2 potassium, 2 potassium, 2 nitrogen, 2 nitrogen. 2 times 3 oxygens is 6. 2 times 2 oxygens is 4, plus the 2 oxygens from over here is 6. So that gives me a total of 6 oxygen and 6 oxygen. Alright, these are just some examples of the classwork and homework that we started. And as you go through the homework, just be mindful of the type of equations that you're dealing with. You just never know what you might have to add to get the right numbers on the other side. So do this in pencil and experiment using different numbers. If you see you have an odd number, for example 3 on one side, but an even number on the other, you might have to increase your coefficient by 2, 3, or even 4 to make sure it all multiplies out. So do this, do the rest of them. We'll talk more about it tomorrow. And as you're doing the work, use pencil or something erasable. It'll really help you out. I hope this helps. See you tomorrow.